Welcome to part 6 of our 9-part series on assessment. This time we're looking at item analysis in the context of a single classroom. We'll be able to look at broader item analysis in our next part. Of course, we ask ourselves, why would we do item analysis? Followed by the 3 key indicators: difficulty, discrimination, and bias. So to start off with, why would we do item analysis? The primary reason is quality control. We want to make sure that the assessment items we are using to evaluate our students are actually doing and measuring what they're intended to measure. They need to be doing what they're intended to do. If the question does not represent the student ability in the course, it should not be a factor of their grades in the course. We also want to make sure that the report card grade actually represents the amount of student learning that has taken place. And again, for that, we need quality items. So the first measure of the item quality we look at is difficulty. The difficulty is a question of how hard the item is. The calculation that we use for it is to take the average score on the item across the class and divide it by the maximum score possible on that item. So for a lot of multiple choice, numeric response, and a lot of machine scored questions, the item will have a maximum possible score of 1. So what we're really doing is figuring out what proportion of the class got the question correct. So a higher difficulty score means easier questions, because again, it is the proportion of the class getting it correct. Now, if it's a question out of 4, we can still take the average student score divided by the maximum possible score, but we're no longer looking at the percentage of the class that got it correct. We are looking at the average performance of students on that particular item. So it's almost like when you calculate the average for the assessment as a whole, except we are doing it on a question-by-question basis. Now, there's some disagreement in the literature about what the ideal item difficulty is, and some of it is fine-tuning according to how many multiple choice options there are and so forth. But all of the numbers I've seen are in that 0.65 to 0.8 range. So you want 65 to 80% of the class to be getting the item correct. If 100% of the class gets it correct, you are not learning anything about what those students know. They all know it. Same thing if 0% get it correct. None of them know it. We need to understand where they're at and guide them. Discrimination is also a key factor. So it's a way to measure not just how different the top performers and bottom performance students in the class are doing, but it is a way to see how many students are getting it correct just by guessing. So to calculate the discrimination, you start by sorting the entire class by their grade on the assessment as a whole. So not just this one item you're interested in, but across the entire assessment. You then split the class into 3 or 4 groups. Most teachers would find that 3 groups is going to work best statistically. If you are a college or university prof where you've got class sizes in the triple digits, then you might break it into 4. But 3 is the most common. You then figure out the average performance of the students in the top group and the average performance of the students in the bottom group, and subtract the average from the bottom group from the top group, and then divide it by the maximum possible score. So, if every one of your top performers gets the question completely correct, and every one of your bottom performers gets the question completely wrong, you'll have a discrimination of 1. A good discrimination is 0.4 or better. If you have an item of very low or very high difficulty, you're going to have poor discrimination because so many students are getting it correct. If every student in the class gets it correct, discrimination is 0. If you have an average discrimination of 0, this probably means that everybody's guessing, and nobody is coming up with the right answer on their own. If you have a negative score, that means the students who tend to do worse on the assessment as a whole are more likely to have gotten that question correct than your top performers. that is usually an indicator that the item is miskeyed. So the answer key says that the correct answer is C, but it's actually B, or something along those lines for multiple choice tests. So a negative discrimination should send you back to your assessment and make sure that that question is keyed correctly, in which case you might want to rescore the test afterwards. So a good item discrimination will tell you that yes, the item is performing, not because it's a good idea to separate top and bottom performers. We want to get every student up to the top performing category. But it is a good idea because that way you know that those who are answering the question correctly are more likely to be doing it by deduction and not by guessing. They're actually solving the problem as it should be solved. Now, I teach in the province of Alberta, and they release some of their standardized test items afterwards. And I've had teachers question, well, if only 26% of the student population got this question right, why was it on the diploma? It's a lower difficulty than we're looking for, and it's very close to 1 in 4. And on a 4-point multiple choice question, that tends to imply that the students were guessing. Well, the answer for why that item was there, even though it was field tested before the diploma, is probably in the discrimination. If only 26% of the population get that answer correct, but those 26 all come from your top performing group, then the question is doing its job, and the bottom performers are being drawn to the incorrect distractor answers as they are supposed to be. So it's still a difficult question. We're not necessarily happy with that 0.26 difficulty. But the discrimination might be telling the province they are not guessing. Those who are getting it right actually are deducing it, and they're just picking up on things that others are missing. The final key indicator is bias. So this will tell you if socioeconomic factors are coming into play in a given question. So to figure this one out, it's very similar to discrimination, but instead of separating things by top or bottom performers, you divide your groups by the factor of interest, such as gender. Right? Do your male and female students perform differently on these items? Now, ideally, we want these measures to be 0. If you find that male or female students outperform the other group, well, then you have to ask yourself, is there a bias in the question? Or even worse, was there a bias in the instruction that prepared the students to write the test that had this question? So our upcoming lessons. Part 7, we're going to look at some advanced item response theory. If we think about the difficulty as it's described now, it takes nothing into account in terms of the background of the students. If you think of, again, I teach in the province of Alberta, where we have -1, -2, and -3 high school courses. -1 is for students who finished grade 9 or junior high with a 65% or greater. -2 are for those in the 50 to 65 range, and -3 are for those below 50. Well, a single question item with an outcome that's in more than one of those courses will probably have different difficulty scales in the different classes just because of the student backgrounds and how strong they were coming into the course. So we're going to see some techniques in our next part that will help us take that into account. We will then see how we can take all those techniques and apply it to computerized adaptive testing before we wrap up this series with a lesson on non-parametric item response theory. Thank you for listening.